Well, we find ourselves in chapter section 6-5, operations with radical expressions. And now we're here at example 2, which we find on page 416 in our textbook. And we're being asked to simplify expressions with the quotient property. And so let's see what we got here. This is guided practice 2A, I believe. Yes, 2A. Again, on page 416 in our textbook. And we have here the square root of a to the 9th power over the square root of b to the 5th power. And so right away I recognize here that I have a root in the denominator. And so I think I'm just going to go ahead and choose to rationalize that root in the denominator. And so what I do is the setup's going to be the square root of a to the 9th power over the square root of b to the 5th power times the square root of b to the 5th power over the square root of b to the 5th power. Now, I'm looking at this stage to cancel the square root in the denominator by multiplying two square roots together. Square root times the square root equals what's under the square root. And so when we do this, then I'm going to have here the square root of a to the 9th, b to the 5th, over b to the 5th. All right, so at least I've got the step done to get the denominator rationalized. Now I'm looking at the numerator, the square root of a to the 9th and b to the 5th. Well, let's see here. Let's see, a to the 9th. Let's break it down like this. I could have the square root of a to the 8th and b to the 4th, square root of that, times the square root of a, b, all over b to the 5th. That gets it a little bit more manageable for me, because if I look at, okay, now what's the square root of a to the 8th? Well, the square root of a to the 8th is a to the 4th. In other words, a to the 4th squared gives me a to the 8th. And the square root of b to the 4th is b squared. B squared, if I square b squared, it's going to give me b to the 4th. And that's all times the square root of a, b. And all this is still over, at this time, still over b to the 5th. Let's put a little equal sign here and we'll go down below. All right, so what can I do here? Well, I've got a b squared up top in the numerator and b to the 5th in the denominator. And so the b squared could cancel out, leaving me with b cubed. Cancel out the b squared. And then my final answer in this problem is going to be a to the 4th times the square root of ab over b cubed. All right, these can be a lot of fun. They'll test your skills a little bit. But hey, isn't that what this is all about? Testing your skills? Let's go look at the next one, and it is even more of a tester than the one we just did here. Okay, well, let's look at this second example here in chapter section 6-5, operations with radical expressions, where we're in here in example 2, again on page 416 in your textbook, where we're asked to simplify expressions with the quotient property. And so here we're being asked to find the 5th root of 3 over 4y. And it's this 5th root that's going to make this one a little bit more challenging. But hey, we can handle it. We can go through with it. So I do see, well, let's take this next step. I think I'm going to take this next step and I'm going to rewrite this to be the 5th root of 3 over the fifth root of 4y. Now, again, I've got the fifth root of 4y in the denominator, and so I'm going to go ahead and take this step of rationalizing the denominator, and in doing so, I'm going to come up with something like this, and this is where some of the challenge will come in. I can't just take the fifth root of 4y. Let's just say I did. Let's say I took the fifth root of 4y times the fifth root of 4y. Well, if I multiply those two together, what would that do for me? Wouldn't do a whole lot, because I don't have anything to the fifth root to come out from underneath those roots. So that's not my solution. What I'm going to need to do is what I have right here. To rationalize that, I'm going to have the fifth root of 4 to the fourth, y to the fourth, over the fifth root of 4 to the fourth, y to the fourth. All right, so let's perform our operation on this. Okay, let's stay with us. Let's do the denominator first, and I'm going to have 3 times 4 to the fourth power. Let's see, what is 4 to the fourth power? Well, 4 to the fourth power is 256, and if I multiply 3, that's going to be 768. So now I've got the fifth root of 768 y to the fourth. Okay, and then in my denominator, I'm going to have the fifth root of 4 to the fifth power times y to the fifth power. Because I've got 4 times 4 to the fourth power, that's 4 to the fifth power. Y times y to the fourth power is going to give me y to the fifth power. Now, I can begin to start simplifying this. Now, let's see, on that denominator, 768, it's an awful big number. But what I want to do and what my process is, I want to be thinking about, okay, is there a number raised to the fifth power that I can take out of this thing? And I see I got an even number. I'm going to start with 2. Let's see. Okay, so 2 squared is 4. That's 2 to the second power is 4. 2 to the third power is 8. 2 to the fourth power is 16. And 2 to the fifth power is 32. Now I want to see, does 32, can I take 768 and divide it by 32? And it turns out I can. And it's going to leave me with 24. So I can express this now as the fifth root. Let's do it like this. I'll do it one step at a time. Fifth root of 32 times the fifth root of 24 y to the fourth. All right. Now in my denominator, I'm taking the fifth root of 4 to the fifth power, y to the fifth power, and that's just simply going to be 4y. Because these fifth roots right here, taking the fifth root of this stuff raised to the fifth power is going to just cancel those powers and just leave me with 4y. Now, we just went through and discovered that the fifth root of 32 is in fact 2. So I got 2, 24, fifth root, let me get that fifth root up there, 24 y to the fourth over 4y. And I can do a little bit of cancellation here. I can cancel that 2 and reduce this 4y down to 2y. And so my final answer then is going to be the fifth root of 24y to the fourth, fifth root of 24y to the fourth over 2y. Shazam. Now, like I say, it's a little bit challenging. Got to think. I took that big 706. Well, let's go back to the first thing. I had to make sure when I rationalized that number that I was going to raise the powers of the term here under the root to something I could take the fifth root of. And in this case, it had to be 4 to the fourth power, times y to the 4th power. That would give me the 5th root of 4 to the 5th power, y to the 5th power, allowing me to take the 5th root of those terms. And then I had this big number right here, this 768. And I'm trying to think, okay, how do I get something out of here that might be, that I could take the 5th root of, and it be an even number. And probably I should have started out probably just going with to see if I could get the 5th root of 768, but I know that won't happen because of what I ended up doing, which was I'm thinking about, okay, what number could I raise to the 5th power that might be, that I could divide into 768 and also give me an even number, and that was 32. And then once I got that, I had 2 to the 5th power times the 5th root of 24y to the 4th power over 4y. I got a 2y and a 4y that I could simplify down to just 2y in the denominator. And there we go. Here is our answer. Aren't you ready to do some of these yourself? Wow.